Hi, and welcome to the Neuro Revision Lab. Today we're going to tackle wave speed calculations from the Physics Paper 2. You'll definitely need a calculator for this one. The things you're going to need to know first are understanding the two different kinds of waves and being able to label those waves. You're also going to want to be comfortable with simple calculations, specifically rearranging those equations. By the end, though, you'll be able to recall the wave speed calculation. Velocity equals frequency times wavelength. And you're going to practice and complete an exam question using that calculation. Going forward, the key words you're going to need this time are wavelength, wave speed, frequency, and energy. Take some time to write these words down in your revision books. You'll need to practice spelling and sounding out each word, and listen carefully to how these words are used. You can research their definitions later. Wave speed, like most physics calculations, are not actually that difficult. It's usually just a matter of multiplication or division. The trick is recalling the correct equation and rearranging it appropriately. To calculate wave speed, the equation is velocity equals frequency multiplied by wavelength. It's displayed here as v, which is the wave speed, and it's measured in meters per second. This is the speed at which the wave is traveling. F, which is frequency, this is measured in Hertz. This is the number of waves passing by in a single second. And finally, lambda, which is wavelength. This is the length of one complete wave in meters. For the sake of reference, some wavelengths are huge and can be meters long. Others are incredibly short and measured on a tiny scale, such as nanometers. We can rearrange this equation, and to help you, I've included an equation triangle. Some people consider equation triangles to be a bit silly, but for our purposes, it makes understanding how to rearrange this equation really easy. All you have to do is cover over the answer you want to find with your finger, and the remaining equation will find it for you. Most importantly, calculating wave speed is essential for tackling the dreaded ripple tank required practical, which will be covered in a very specific separate video. Let's put this calculation into action with an exemplar question and answer. The question is, a wave in a pond has a frequency of 3.5 Hertz and a wavelength of 40 centimeters. Calculate the wavelength in meters per second. The FIFA method works really well in physics calculations, and when used correctly, it will guarantee you get all of the marks in an equation. Let's start with F, which stands for formula. We don't need to rearrange anything here because we want the wave speed, so it simply ends up being V equals F times lambda. So we move on to insert values, which is I. We put in the frequency, which is 3.5 Hertz, and 40 centimeters, which is the wavelength. Now, on to our fine tune. Fine tuning is where we're going to do any conversions that we might need, and in this case, centimeters is not really going to do it for us. So we need to convert centimeters to meters. Using our helpful little chart on the right hand side here, you can see that to turn centimeters into meters, we need to be dividing it by 100. Writing out that equation again, that now becomes 3.5 Hertz times 0.4 meters. Do the calculation and include the units at the bottom in A, which is your answer, and it is 1.4 meters per second. At this point, your revision should probably look at least a little bit like this. Feel free to pause the video here. Make any corrections you feel are necessary. Make sure you understand how to use that wave speed equation before we try a couple of exam questions. Okay, so let's give these exam questions a go. I've given you two standardized mid-level physics GCSE questions. I've also included the FIFA table at the bottom and the equation at the bottom right, just so you've got some useful tools to remember. Question 1. A sound wave travels through air with a frequency of 250 Hertz and a wavelength of 1.4 meters. Calculate the speed of the wave. Question 2. A wave travels at a speed of 0.75 kilometers per second and has a frequency of 150 Hertz. Calculate the wavelength of the wave in meters. Don't forget to highlight your command words, which will tell you what you need to do. In this case, it's easy, calculate. Your keywords and your values, which you are absolutely going to need this time to plug into your equation. Pause the video here, good luck, and we'll have those answers for you in just a moment. For more revision resources, tips, and helpful materials, please visit the NeuroLab store. Everything here is specifically selected or made for neurodivergent learners. And as an added bonus, each purchase supports the channel and allows us to keep producing video content. And as usual, subscribe, like, and share the channel. Okay, so here are your answers. A sound wave travels through air with a frequency of 250 Hertz and a wavelength of 1.4 meters. Calculate the speed of the wave. We won't need to rearrange the equation as it's the speed of the wave that we're trying to find. So it simply is frequency times lambda, which when we put our values in I, it becomes 250 times 1.4. We've got no fine tuning to do. So we simply do the calculation and it becomes 350 meters per second. Let's try something a little bit harder. This one is decidedly more difficult. A wave travels at a speed of 0.75 kilometers per second and has a frequency of 150 Hertz. Calculate the wavelength of the wave in meters. This time we need to rearrange the equation to make wavelength the focus. So in your formula box, that really should be velocity divided by frequency. Then in insert values, we can put in 0.75 over 150. But as we go down to fine tune, we're then going to need to convert those units into meters per second. So we need to times it by 1000. Then we do the calculation. 750 divided by 150 equals 5 meters. You will have a wavelength of 5 meters. Well done in completing your wave calculation revision. As always with calculations, practice as many of these equations as it takes to feel confident. If this video helped, then you'll love our specialist neurodivergent notebooks, designed to make learning clearer and easier. They feature partitions in the Cornell note-taking style on pastel colours, with all the resources to make learning GCSE science just a little bit easier. They're an amazing addition to EHC plans or just as a useful accompaniment to revising at home.